hypergolic fuel explosion, jettisoning the W-53 warhead beyond the launch site, nuclear testing and fallout. Over 500 atmospheric nuclear weapons tests were conducted at various sites around the world from 1945 to 1980. Radioactive fallout from nuclear weapons testing was first drawn to public attention in 1954 when the Castle Bravo hydrogen bomb test at the Pacific Proving Grounds contaminated the crew and catch of the Japanese fishing boat Lucky Dragon. One of the fishermen died in Japan 7 months later, and the fear of contaminated tuna led to a temporary boycotting of the popular staple in Japan. The incident caused widespread concern around the world, especially regarding the effects of nuclear fallout and atmospheric nuclear testing, and provided a decisive impetus for the emergence of the anti-nuclear weapons movement in many countries. As public awareness and concern mounted over the possible health hazards associated with exposure to the nuclear fallout, various studies were done to assess the extent of the hazard. A Centers for Disease Control and Prevention National Cancer Institute study claims that fallout from atmospheric nuclear tests would lead to perhaps 11,000 excess deaths among people alive during atmospheric testing in the United States from all forms of cancer, including leukemia, from 1951 to well into the 21st century. As of March 2009, the U.S. is the only nation that compensates nuclear test victims. Since the Radiation Exposure Compensation Act of 1990, more than $1.38 billion in compensation has been approved. The money is going to people who took part in the tests, notably at the Nevada test site, and to others exposed to the radiation. In addition, leakage of byproducts of nuclear weapon production into groundwater has been an ongoing issue, particularly at the Hanford site. Effects of nuclear explosions. Effects of nuclear explosions on human health. Some scientists estimate that a nuclear war with 100 Hiroshima-sized nuclear explosions on cities could cost the lives of tens of millions of people from long-term climatic effects alone. The climatology hypothesis is that if each city firestorms, a great deal of soot could be thrown up into the atmosphere which could blanket the earth, cutting out sunlight for years on end, causing the disruption of food chains in what is termed a nuclear winter. People near the Hiroshima explosion and who managed to survive the explosion subsequently suffered a variety of horrible medical effects. Some of these effects are still present to this day. Initial stage, the first 1 to 9 weeks, in which are the greatest number of deaths, with 90% due to thermal injury or blast effects and 10% due to superlethal radiation exposure. Intermediate stage, from 10 to 12 weeks. The deaths in this period are from ionizing radiation in the median lethal range, LD50. Late period lasting from 13 to 20 weeks. This period has some improvement in survivors' condition. Delayed period, from 20 plus weeks. Characterized by numerous complications, mostly related to healing of thermal and mechanical injuries, and if the individual was exposed to a few hundred to 1,000 millisieverts of radiation, it is coupled with infertility, subfertility, and blood disorders. Furthermore, ionizing radiation above a dose of around 50 to 100 millisievert exposure has been shown to statistically begin increasing one's chance of dying of cancer sometime in their lifetime over the normal unexposed rate of 25%. In the long term, a heightened rate of cancer proportional to the dose received would begin to be observed after 5+ years, with lesser problems such as eye cataracts and other more minor effects in other organs and tissue also being observed over the long term. Fallout exposure. Depending on if further afield individuals shelter in place or evacuate perpendicular to the direction of the wind, and therefore avoid contact with the fallout plume, and stay there for the days and weeks after the nuclear explosion, their exposure to fallout, and therefore their total dose, will vary. With those who do shelter in place and/or evacuate, experiencing a total dose that would be negligible in comparison to someone who just went about their life as normal. Staying indoors until after the most hazardous fallout isotope, I-131, decays away to 0.1% of its initial quantity after 10 half-lives, which is represented by 80 days in I-131's case, would make the difference between